So in this lesson, we look at these things called similar triangles. Now, you might know what similar means. Similar is when things are kind of sort of the same, but not exactly the same, because if they were exactly the same, they would be congruent. So similar is when things have commonalities, but they're not exactly the same. So in terms of triangles, when two angles in one triangle are congruent to two angles in another triangle, the third angle is congruent and the triangles are similar. So there are two triangles that are not necessarily the exact same size, but they have all of their angles the same measurement. And the symbol for similar is a little squiggle. It's kind of like the congruent symbol, because similar and congruent are kind of in the same family. So the congruent symbol is the equal sign with the squiggle on top, and similar is just the squiggle. So let's use that rule to figure out if these triangles are similar. So we've got a 75, a 50, and an X, and we've got a 75, a 50, and a Y. Well, if they both have 75 and 50, and the total number of degrees in a triangle must be 180, then X and Y have to be the same, but you can calculate it to figure it out, so you get your calculator. 75 plus 50 is 125, so 180 minus 125 is 55. So this is 55. But obviously this is also going to be 55 because it's still 75 and 50, right? So it'd still be 180 minus 125. So if they have all of the same angle measurements, then yes, they are similar. All right, let's look at the next one. So in this triangle, we have 63 and a 54. And we have two 63s. So it doesn't necessarily mean that they're not similar, because this could be a 63 and this could be a 54, and then they're all the same. So you have to actually calculate it. So 63 and 54 is, I'm trying to do mental math, that is 117. So then when I subtract, I get 63. Oh, so they are, right? Because 63 and 63 is 126. And when you subtract that, you get 54. So see, just because it didn't look identical from the beginning, doesn't mean that they're not. So these are also similar. All right, why don't you try example 3 and 4 on your own? All right, check your answers and fix any mistakes that you had. Oh, whoops, that says 66.
Indirect measurement is something that real-life careers actually use. It's when you use similar figures to find a missing measurement that is difficult to find directly. So this is just one example, but if you think about all the bridges that are built, nobody's getting a tape measure or a ruler and dragging it across the ocean or across the, waterways in Fall River and in Providence. They're not measuring those directly using objects. They have to use certain tools to figure out the actual distance across the water so they can make sure they have enough materials and make sure that they put the supports in certain spots so that the bridge doesn't collapse while you're on it. I know that's terrible to even think about. So example 2 is just an example of trying to find the distance across a river. You plan to cross a river and want to know how far it is to the other side. You take measurements on your side of the river because you can, and make the drawing that you see right here. So we have to explain why the two triangles are similar, because if the triangles are similar, then we can create proportions like you did back in chapter 2. And the way that we're figuring out if things are similar, if triangles are similar, is based on this lesson that they have two angles that are congruent. So I know they have at least one congruent angle. They both have a 90. So obviously that's one angle. Let's write it down. If we can find one other angle that's congruent, then we have proven that they're similar. Can you figure out which one is congruent? If you are skilled with recognizing vertical angles, this angle right here, oh sorry, I used the same color in the picture. Let's use blue. This angle right here matches this angle right here because they're vertical, and vertical angles are congruent. So again, I'm looking at this angle here in triangle ABC and this angle here in triangle CED. Since those are vertical angles, and vertical angles was one of our congruent vocabulary words, then angle BCA is congruent to angle DCE, and therefore that's congruent to the other one. So what I've written down is angle BCA is congruent to angle ECD. Since I've proven that they both have two angles that are congruent, I've done the work of proving that the triangles themselves are similar. So I've written, since the triangles have two congruent angles, the triangles are similar. Now that I've proven that the triangles are similar, I can use the concept of proportions that we learned in the last chapter to find the missing measurement. So remember, if from chapter 2 you find the two sides that match and you make them into a ratio. So I'll match up the 40 and the 50. And that's going to be equal to 60. Nope, sorry, 40 is from the small triangle. So x has to be on the top. X over 60. So I want you to pause the video and solve this and tell me what x is. So when I solve it, I get x equals 48 feet. We will practice more of these when I see you in class, and if you have any questions, write them down.